Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll illustrate some of the options we have inside our ToolBox operation. Now, if you take a look at this part, we have actually here every single option that is available in ToolBox done on the part itself. But we're only going to take a few of them so that you can get an idea of what the actual toolbox is. First, we'll start off with this slot as shown over here. This is a wide slot where I'd like to actually go in, mill down the center, and then clear off towards the side. So for that, we've used the option inside of Toolbox called Additional Zig Zag Slide. Now, if I were to open this, you can see that we have all of the options over here, and I've just chosen the one that I needed, the additional zigzag slot. The geometry I've chosen in this particular case was this around over here. The directions in this particular case does not make a difference. The tool that I will be using will be a 10mm end mill, which is less than the width over here. And of course, we have our levels. Now, in my technology field, we have our step down, we have our ramping width, the actual width of the ramp as it zigzags down into the part, and our maximum ramp angle that we have over here. Then we have our parallel cuts as it moves towards the sides over here. These are all the parameters that are needed to do this operation. The idea behind this is to make it as simple as possible without having to deal with any extra type of parameters. If I were to run my simulation in this particular case, you see that the tool will go down, zigzag into that area, and then move across. Then it will actually start stepping over on the part as shown over here until it finishes that particular operation as shown over here. Now, in our next operation, I like to work in this particular area over here. This is what we call a simple slot. All we want is to have the tool go down, across on one side, then go directly to the other side without going up to its clearance area, and then coming back down. And I'd like to do this without having to create a chain that goes across over there as well, just by picking these two elements. So for that, we have our operation called Simple Slot, where all we do is pick these two edges as shown over here, and we have our tool. Our tool in this particular case is a 16mm end mill. We have, of course, our levels, and then our technology. In our technology, we have our step down. We have wall offset if you want to keep it away from the wall, not to finish it. And if we want, we can also just finish the wall as well, if needed. And that's all the parameters that I really need. Running my simulation, you'll see that the tool will go down, across, to the other side, and then come back up. And you'll note that it did not go up in this area. It went directly across to the other side. Next, I'd like to work on this slot over here. This is a completely closed slot, and in this particular case, we'll be using a tool that's the exact diameter of this area over here. So that all we need to do is just go back and forth in the slot itself. If we were to open up the operation, you'll see that we've used the option over here called Closed Slot. We have our geometry as shown in the diagram over here and on the part itself. And of course, we have our tool. Our tool is a 12mm end mill, which is the exact diameter needed for this area, as this is a 6mm radius. We have our levels, and then we have our technology. In our technology, we have our step down, and our step down actually zigzags into the part itself. It actually ramps into the part as it steps down. We have our floor offset if needed. And the actual step that we'll be having, as we'll see in our simulation, is as follows. The tool goes down into the part itself, goes across. And note it zigzags back and forth into the part itself. And then when it gets to the bottom, it just does one straight cut across the bottom floor, finishing off the floor. Next, I'd like to work on this area over here where we have to clear out a specific corner. Now note, if I were to open up the operation, we have that operation called simple corner as shown over here. And all we have to do is pick out the edge over here. Note that we have to follow the proper direction. If I were to show you my geometry, you can see that all I have here is just this edge. It'll automatically figure out what the area is that it has to clean on the part itself. This is what we call a simple corner. Choose my tool, my levels, and in my technology, I have the following: my step down, my step over in the part itself, and if I want an extension of how much I want it to go past the edge over here. Of course, we have a wall offset and floor offset needed, and finish. We can also have our tool path link either going zigzag or one way as shown over here. Let's just do our simulation of the part itself. And as you can see, the tool go down, clear off the corner exactly the way we need it without going out past that area itself, only cleaning the area that needs to be cleaned. In our next operation, we'd actually like to work in this area over here, which actually demonstrates to us an O-ring. We'll open up the operation itself, and as you can see, we're using the option called O-ring. We have our geometry as shown over here, and we have our tool. Our tool in this particular case is a 4mm end mill, which is less than the width over there. This will allow us to actually go down in the middle and then clear off the sides. We have our levels, and then we have our technology. In our technology, we first have our rough, and then we also have our finish. Our rough is our actual area where it goes down, clearing out the middle. And we have our step down. And in our step down, it actually ramps through the part in a helical fashion into the part itself. And then we have our wall finish as it steps down directly on the wall itself. If we were to take a look at the simulation, and we'll do this looking into the part itself as shown over here, you can see as we zoom in that the toolpath is actually helicaling into the part itself. And then when it gets to the bottom, and I'll switch now to the top view, you'll see that the tool actually clears one side and then clears the other side as well. Next, let's take a look at the option for clearing out round pockets as shown over here. For that, we have the option called spiral pocket, where it actually cleans the pocket in a spiral fashion, which is the most efficient way to clear out a circular pocket. Our geometry is the actual edge of the circle itself. And of course, we have our tool and our levels. In our technology, we have our step down, and then we have our minimum cutting angle and our maximum cutting angle inside the spiral itself. We have also our helical ramping angle as it ramps into the part itself back and forth up until it gets to the very bottom. If we want, we can also use an offset, and we also can do a finish cut at the very end. Let's just take a quick look at the simulation itself. You'll see that the tool path goes down, helicals into the part itself, and then as it starts going around the part, and we'll move to our top view for this, you can see that the tool will actually be working in a helical fashion, being the most efficient way to clear off that particular circle as shown over there. Now, the last operation I'd like to show you is actually designed for wood cutting. What I'd like to do is demonstrate on this block over here as if this was a piece of wood, and I wanted to cut off the edge over here with excess material on the other side. So if I were to open up the operation, you can see, as in the diagram, exactly what I want to do. we have the option of wood cutting as shown over here, and we have our geometry as shown over here. We have our tool, and in this particular case, you can see we have a special tool specifically for wood cutting as shown. We have our levels, and then we have our technology. In our technology, we have our first step down, so we don't have to go down all the way in our first cut. And then our second cut will be our final cut. Taking a look at the simulation itself, you'll see that the tool will actually go down across the part, but not all the way to the bottom, then go back up, go back down again, and then finish off cutting the part. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.